Okay, in this video I'll do this problem, which is a number of arguments where we're supposed to do logical arguments, and there are A through F of them, but you'll see they're not too bad. Part A, it gives as a premise P or R, and then it also tells us as a premise that if you have P or R, then you have S. Well, we directly conclude S due to direct inference. Okay. That's all you need there. Direct inference rule says if you have P and you also have if P then Q, then you conclude therefore Q. Well, we've got the same thing, except instead of just a plain old P here, we have a P or R. Okay, and instead of a Q, we have an S. Okay, so the pattern is what's important here. Okay, so there's really nothing to prove here. That one's just a simple example of direct inference. If we move to part B now, it says that if we have not P, then Q and R. It also says that we have not P and S, and it asks us to conclude R. So what I'm going to do is I'm going to say that not P is true due to not P and S as a premise. And you can call that one of the rules. I don't tend to remember the names of these rules, and so then because we have not P, and we have not P implies Q and R, then I can conclude Q and R, okay, which is direct inference. Okay, and if I have Q and R, then I can conclude R due to Q and R. Okay, so those are the results of some of the rules that we've had, and so we've done it. We've completed the argument there. Okay, we've shown why each step is true. Okay, so let me draw a line here, and I'll do part C next, which says that as premises we have not P or R implies not Q, and we also have Q, therefore P. And what I'm going to do here is I'm going to say as the first step, Q implies it's not the case that not P or R. And that is the contrapositive of one of our premises. And the contrapositive reverses the order and also negates both sides. And then I'm going to rewrite this contrapositive and say Q implies, now I'm going to apply De Morgan's law to this here, and I'm going to say P and not R. Okay, this is De Morgan's. I think I'm supposed to use a capital D, E. Okay, now I can conclude, because I have both Q as a premise and I have Q implies P and not R, I can conclude P and not R due to direct inference. Okay, finally, from P and not R, I can conclude P, much as I did in part B. And I'll just say since P and not R, because I don't remember the name of that rule. And you don't have to either. It's more important to remember these things and be able to use them than to remember their names. And I feel that is the case. Okay, so that does it. I got my conclusion. For part D, it says P or Q, the quantity P or Q implies R. It says not R is the case, and it also says T implies Q, therefore not T. Let's see if I can see my way through this argument. I'm going to go ahead and say that not R, along with this implication up here, means that it's not the case that P or Q, which means with by De Morgan. Okay, so that was by contraposition. If I take the contrapositive of this if-then statement, I get a not R. If a not R, then not that other thing. And once I get that, I'm going to apply De Morgan's to that, and I'm going to say not P and not Q. Once I have not Q, I can do the same thing here on T implies Q and say that not T is my conclusion. So I can see my way through it. I'm going to go ahead and write not R implies not P or Q due to contrapositive of a premise. And then I'm going to conclude that not the case, P or Q, due to direct inference. And I conclude that because I have both this if-then statement and I have not R as a premise. And then I'm going to apply De Morgan to say not P and not Q. And then I'm going to conclude from that not P. No, I'm going to conclude from that not Q, because that's the one I want to use next. Since not P and not Q. And then from not Q, next I'm going to go ahead and write the contrapositive of if T, then Q. And I'm going to say if not Q, then not T. Contrapositive of a premise. And finally I can conclude, because I have both not Q and I have not Q implies not T, I can conclude not T due to direct inference. Okay, so that one involved multiple steps, but hopefully you can see where they all came from and where they all went. And now I'm starting to run out of room a little bit here, but I think I have enough. Okay, let's see if we can see our way through part E. Oh boy, I need to conclude both R and U. Well, I can get R from this, from if I have P and not P or not Q. Here we go. I have both S and P. So I can conclude P, and that gives me P or not Q, and that gives me R. And from S, I get T and U, which means U is true, and so I have both R and U, and I can finish it off that way. Okay, so the first thing I'm going to do is I'm going to say S is true since S and P are both true. Then I'm going to conclude that T and U is true by direct inference. Then I'm going to conclude that U is true, since both T and U are true. I'm also going to conclude that P is true, since S and P are both true. P is true. And if P is true, then P or not Q is true, since P is true. P or anything is then true. And finally, I conclude R by direct inference. Because I have both P or not Q, and I have P or not Q implies R. Finally, I have both R and U being true here on my list. And so I'm going to conclude that R and U, since both R and U true. Okay, so I did it again, multiple steps, but hopefully not too bad, and you can see how it works. Finally, part F, P implies Q implies R, and I have Q, and therefore P implies R. So it makes sense. If I assume that P is true, then I'm going to get Q implies R, Okay, I'm going to do a conditional proof on this. I need to prove if P then R. Therefore, I'm going to show that R is true on the condition that P is true. Okay, I'm going to say, suppose P, and we show R follows. That will prove P implies R. Okay, that's just what a conditional proof is. So let's suppose P, then Q implies R by direct inference. Because I had both P and I had P implies Q implies R. Now I have Q though, and so I can conclude R. Since by direct inference again, since I had both Q implies R here, and I had Q as a premise. Okay? Hence, that's what we wanted to show. We wanted to show that R follows, and we just got it. Hence, P implies R. Okay? So, hopefully that's clear, and hope that helped.